So something else that's important with Golang is in the Golang spec, and we're going to look at value types. And so in the Golang spec, the language specification, you could go to types, and you can see, you know, we were working with int, numeric type, right? You'll find under numeric type that one of them is int, and we'll look at that more in a second. But first, let's get the high-level overview. So we have Boolean types. A bool is something that's true or false, right? So that's what you could set a bool to, true or false. And numeric types would be like an int or a float. String types, strings. And we have arrays, slices, and structs, which are all data structures for storing data, right? Pointer type, which is instead of passing around a chunk of data, we could pass around a memory address where that chunk of data is stored. So that makes our program more efficient. And so, you know, if I'm storing the whole phone book, instead of passing around all of that data through my program, which takes up resources, I could just say, hey, all that data is stored in that spot, and pass around the address where that data is stored. We could pass around function types, interface types. Those of you with programming experience, this is what interfaces define functionality, right? So you just declare a type with certain methods. When it has those methods, it implicitly implements an interface. You don't have to explicitly declare it like in Java. You don't have to say, hey, this implements that interface. And then it allows polymorphism. So you could have one function take something that implements a certain interface type, and anything else that implements that interface type can be passed into that function. Maybe we'll get to that. And then maps and channels, right? Map is another data structure type for key value pairs, and we'll go over data types. And then channels allow you to do concurrency, and you do communicate between channels, or communicate between concurrent Go routines by using channels. And so that's how you share memory. So share memory by communicating, don't communicate by sharing memory. They have some phrase which doesn't make something like that, but anyhow, that's what channels are for. And I have examples and all that. And then we have method sets. Yeah? But we'll get to all that. And you can look at those later. But I want to just look at the numeric type for a second, because this kind of, when I was just getting into programming, December of 2014, I've been at it a year, and I was like, oh dear, and I've done some Java and some Python at that point, and I'd taken this great course at Coursera in Python, Coursera.org has this Python course, not Coursera, I want Udacity. And Udacity has this full stack intro to programming. Learn to code. Catalog. I just want to point it out because it's cool. They've changed everything. It looks different. Oh, this is what I remember. I like seeing the pictures of the people. Because I just look for the picture of the dude that I took it from. Where are you, man? Wow. Oh, here he is. Intro to Computer Science. Beginner. This is one of the hardest classes I've ever taken in my life. And it's great. 543,467 students have taken it.
A free class?
Yeah. And it's really great. And I've signed in before, so I'm going to pause the video while I do this. So now I'm at the course. I just want to illustrate that. And like, here's the course, and it goes all the way down. You know, and so like this introductory lecture, right? We saw that 546,000 people were enrolled, but only 36,700. And this is the intro. This is like video 1, 36,740 views, right? So that's a lot, right? Lesson 1, introduction. Well, what happens when we get down to like lesson 7? And let's open that up and look at like, you know, I don't know, theory of computation. Like, what did it start out at? 36,000? Like when I was like going through this course, you know, in 2014, and like, you know, it started out as like, I don't know, at that point it was like 15,000, but like really quickly, like by level, you know, section 2 is like 42 people that watch this video. And then like by section 3, it's like, you're the 13th person that's watched this video. I'm like, this class is kicking my ass. How is this a beginner class? It was and then at the end, we created the same algorithm which Larry Page created to start Google. Of course, a beginner class in Python with like recursive, like, you know, and stack and add the URLs and pop them off. And it's like, and then you do an interview at the end, and you have to talk to the engineers at Udacity, and they look at your code, and then if you did good, they give you a certificate. You have to pay for that. That's like $200. It was awesome, though. So anyhow, when I got here and looked at all these, I was like, oh, dear Lord. I have to distinguish between like int 16, 32, 64, and this is like, I'm going to use 8 bits and 16 bits and 64 bits, or 32, and what's a uint versus an int. So this is unsigned, meaning there's no negative, it's just all positive. So, you know, if I had 8 zeros and ones, I could store 256 characters. For a free piece of candy, how many people, who could tell me why uint 8 will only store 0 to 255? It's 8 bits. Well, it's 8 bits. Binary, tell me more.
So you represent 0 to 254.
You got it. It's 2 to the power of 8, right? So if I have 2 to the power of n is how you figure out how many things could be represented by whatever number of switches you have. If I have 1 light bulb on my porch, I got 2 to the power of 1 light bulb. I could represent 2 things, on, off. Come trick or treat, go away. 2 things, right? If I have 2 light bulbs, I could represent 2 things, both on, both off. This combination of on, off, opposite combination of on, off. 4 different states of on, off. I could assign those to a certain coding scheme. And it could be, you know, bring beer is if they're both on, right? Go away is if they're both off. Like still single is if the right's on, left's off. And, you know, I don't know, bring beer and pizza if it's the opposite or whatever it is. And so, you know, that's 2 to the power of 2 gives me 4. 2 to the power of 3 would allow me how many possible combinations of on and off if I had 3 light switches? 2, 2, 2. 2 times 2 is 4 times 2 is 8. So I could do 8 with 3 light switches. 2 to the power of 4, if I had 4 light switches, how many possible on-off combinations? 16. 2 times 2 times 2 times 2 is 2 times 2 is 4 times 2 is 8 times 2 is 16. So 2 to the power of 8 is 2 times 2 is 4 times 2 is 8, 16, 32, 64, 128, 256. Why is it not 0 to 256? Because that would be 257 possible spots. And you can only store 256, and 0 is a spot. We started out at 0. So a lot of indexes and things start at 0 in programming. And, you know, so anyhow. So to the 16, we'll go to 65,535. Because there's 65,536. 2 to the power of 16 is 65,536. And so on and so forth. So that's unsigned. It's all positive values. Here is int. And it'll do negative 128 to 127, which is 256 values. Right? Or the negative. So that's the difference between a uint and an int. Then we have floats, which does decimal points. Right? And float 32. I'm like, geez, dear Lord, I don't want to have to just figure out which is how much, whatever, for each spot. Luckily, you can just use int right here. So there's pre-declared numeric types with implementation-specific sizes. So int is the same as size as a uint. So a uint is right here, either 32 or 64 bits, and it's implementation-specific. So, that's kind of trippy. And if you just read this, you'd be like, I don't know what the hell that means. And when I first read it, I was like, I don't know what the hell that means. And even when I read it right now, I was like, uh-oh, I don't know what the hell that means. But luckily, somewhere in the back of my mind, I remember Bill Kennedy saying, mechanical sympathy. Bill Kennedy lectures a little bit like he was part of like Mussolini's regime maybe. Or, you know, he's just very like, he's a dictator in the classroom. And I don't know how else to describe it. I kind of lost myself trying to choose the right words, and those weren't quite the right words. But implement mechanical sympathy. Go is written to have sympathy with your computer, to be mechanically sympathetic, right? These are machines, they're mechanics. And so mechanical sympathy means what kind of a computer am I running on? And can I run well on that computer? And if you're a 32-bit architecture, right, then it's going to be, int is going to be 32-bit. It's going to be int32. So it's same as uint. So it's going to be either 32 bits or 64 bits, right? So int's going to be 30. If you're on a 32-bit architecture, it's going to be int32. And I'm just wondering, is it int or uint, right? Because int, same size as a uint. Same size, not same as a uint. It's not just another word for uint. It's the same size as a uint. So it's going to be int32, which means these values right here. If you're on a 32-bit architecture, if you're on 64-bit architecture, it's going to be those values. Why is that good for performance? Because 32-bit infrastructure architecture is going to handle that well, and 64-bit can handle that well. What does that mean, 32-bit or 64-bit architecture? 64, that's the word size of the computer. Hold on. Hello? Hi. So the word size of a computer is how many zeros and ones can it process at one time. So 32-bit architecture can process 32 zeros and ones at one time. And 64-bit architecture can do 64 at one time. So that's mechanical sympathy, right? And so it'll determine that based upon what it's running on. And so that's int, and that's uint. So you could use int or uint, and it just determines what kind of machine I'm running on, then chooses between 32 and 64. So if you know you're going to be on a 64, you don't need to specify it, right? But if you're like, well, crap, I'm going to get a number bigger than int32, and it might run on an int32, I'm always therefore going to specifically specify int64. So even if I'm on an int32, it's still going to be able to hold these big numbers. It's just not going to be quite as fast. Does that make sense? Right? But in most cases, you just say int or uint. And then there's the rune thing, which is an alias for int32. Why is rune alias for int32? What is a rune again? It's a character. And what kind of coding scheme do we use in Go? What kind of coding scheme's used? UTF-8. And UTF-8 is a 4-byte coding scheme. 4 bytes is 32 bits. So it's int32 because it'll use either 1 byte, 2 bytes, 3 bytes, or 4 bytes, depending upon the character it's encoding. And so to encode a character, a rune, which is just a number which in a coding scheme points to a certain character in some alphabet, it's int32. Pretty interesting, right? Rune. And a byte is a uint8 because a byte is 8 bits. Whoa, pretty cool. But this stupefied me for months when I first started Go, particularly when somebody was trying to explain it to me in Chinglish. You guys know Chinglish, right? You ever Googled Chinglish if you've never done that? Chinglish is awesome. I love just like sometimes going and just looking. I went to China. Grants are amazing. Deformed man toilet. No idea what that is. Get straight on public. WC, emergency exit. That's not so funny. Slip carefully. Carefully bang head. Crack, nourish food. Not sure what that means. Spread to fuck the fruit. I don't know what that's about. Care for life, do not fund. If you have any trouble, please feel free to hang your employees. Do not disturb tiny grasses dreaming. So I went to China, and I'm just going to pause the video here. And I don't know, maybe I won't. I'll give you the personal anecdote in a second about Chinglish. There's a little bit more, but we'll finish up with types. So that's numeric types. Then we have string types, and we have the bool type, right? And so you could read about string, but it's just, basically, hey, I've got some characters I want to do. Numeric, string, bool. And those are, hey, we've already learned about 3 types. Cool. Let me just see if there's any others I want to point out quickly. And we'll learn about the data structures in a bit. So that's it. That's all I wanted to say on value types. And the ones that we covered here, oops, that's not the place I want to be. The ones we've covered here are numeric, string Boolean, and numeric, we talked about int, and we talked about, oh, we didn't talk about float. So let's take a look at float. So we talked about int, uint, rune, byte, int, uint, rune, byte, and then let's look at float. So float, just use float 64. That's all there is to say about that. Unless you're on a 32-bit architecture, then you might consider float 64. So in practice, talked about these. In practice, use most of the time just use int float 64. And this is capitalizing stuff for me, but that'd be lowercase. I'm not going to try to uncapitalize it because it's a pain. All right, so the next video we're going to talk about functions, and it's going to be lunch.